Alright folks, in this topic we're going to talk about Gmaw. I think I just like saying that sometimes. Or gas metal arc welding. Now, although we dealt with shielded metal arc welding, technically a gas metal arc welding is actually also a shield metal arc welding, except they use a gas to create the shielding effect. So whereas SMAW, basically your shielded approach, used the flux around it and the destruction of the flux to create the gaseous shielding effect right there. This is a really bad example, but you kind of get what I'm going for. They use the flux to actually create the gas shielding. With gas or Gmaw, the gas shielding is built in. So basically it omits the flux. So for example, your conductor, which is also your filler, no longer has this flux on the outside of it. So it's just basically a wire. So out of your handle just comes a wire, which is both conductor and the filler material, and the shielding effect is brought on by a separate gas effect. So basically gas is being used to create the shielding without the filler being used. Let's take a look at a picture. First off, if Gmaw is established, once again it's going to be in the tail end of your welding symbol. And you basically have this particular setup right here. You've got your equipment, your your welding box essentially, where the electrical components are going in and electricity may be converted or rectified or whatever the case may be. You do have a wheel of electrode supply, and you have a shielding gas tank. Now, unlike some of the previous discussions, this type of gas is actually not combustible, not really flammable, it's not oxygen or anything else. It's going to be an inert gas. And when we say inert, we basically mean that it doesn't react with anything. Helium, for example, is an inert gas. And there's quite a few of them. Carbon dioxide is an inert gas. And we not only will it not react, but it won't really combine things. And that's what we want it to not do. We just want it to be there in presence and not do anything else. Now, why don't we just use typical air? It's because air actually, it has oxygen in it. So combining oxygen to the flame or the explosion that's occurring in the electrical arc may not be the greatest thing in the world. So therefore, your typical MIG machine or your typical MIG welder is built into this. Now, most systems now actually combine the wheel into the box. So let's take a look at some examples. Now here's a pretty inexpensive one. Actually, this doesn't even have the tank to go with it. But anyway, there you go. The actual welding wire will probably be in some kind of, oh great, I got a deal. Will either be in somewhere inside it or above or mounted, that kind of thing. A lot of them are actually mounted inside for protection. And we'll talk about, some of the pros and cons of that. But you have your electrodes. The wire comes out through here, comes into here, and then creates the arcing effect there. They don't sell you a tank, apparently. But you will notice, I don't know if you can see it here in the ad, it actually points out that this actually can run off 120 volt instead of 220, which means that you could plug this in to probably a fairly typical wall outlet if it has the right amperage. Now you will also notice that it actually has some different settings and controls on it. In terms of this, there actually is a change in the way that it operates. For example, on the shield metal or shielded metal arc welding, you'll notice that we talked mostly about changing the amperage. Here, you actually change two dials in this case. One is the voltage, and one is the wire speed, basically how fast the wire is coming out of this. Now, the amperage change is occurring with the actual wire change too. So here, you're changing voltage, whereas in SMAW, you're actually changing amperage. Now, this ability to control the voltage actually means that when you fire up and actually hit the trigger, that it is constant voltage to whatever you have it set to. So it actually is a constant voltage potential, but the voltage can be adjusted to what that voltage value is. Whereas the amperage is being adjusted by your wire speed. So that's one of the reasons that Gmaw welding machines are known as constant potential welding machines, because of that constant set voltage to whatever you set it to. So let's take a look at the actual, the welding gun and the actual nozzle. So right off the bat, you can see pretty quickly, this is not the best image in the world, but you get the idea. You have your nozzle, and you have this little extruder right here where the wire is going to come out. And you may look at this and realize, well, this is actually where the gas is produced or pushed through the actual head, noticing coming around the wire and creating the shielding effect as it comes out. See if I can find us a better graphic. There we go. Take a look at that. There's the wire. There's your actual filler / conductor. And this is your space when the gas is actually flowing through. And obviously these things can get wear and tear over the time. That looks like a little bit better example. Oh, I saw a really good one here. There we go. Well, can't really see it from that size. I'll just have to draw it for you, I suppose. But anyway, let's do that cross section. So if we're looking at a cross section of this, here's your nozzle coming down, and extruder system, here's your wire coming out, and of course the arc's occurring here. The gas is flowing right out this way to create our shielding pocket. And it makes pretty good sense that you're still doing the same thing as your previous shield or shielded metal, except you're just doing it by supplying the gas instead of having burned the flux out. Now technically in the actual hose, if you look at the setup, your wire is coming through, but your gas is also coming through the same hose, even though you can't really see it. Let's go see if we can find one of those welders back there for sale. Come on, Lincoln here. Come on, buddy. Taking it sweet time. Let's use this one right here. That's pretty good size. Okay, so your gas line's coming into the machine, regulators, that kind of thing, and you do have this line. I think we can see it here. I think we're looking at it, right? So you're basically looking at two lines in this one setup. So your wire's coming through, but your gas is also coming through the same hose. Even though it looks like it's the same hose, it's actually two separate ones. There we go. There we can see this one a little bit better. Looks like they got it routed in that way. So essentially the gas is flowing through with the wire, but they're not actually making contact with each other. Hey, look at that graphic. There we go. Sweet. Alright, so hit this image right here, and we can see essentially what we're looking at. Your gun trigger, your button feed, essentially. Wire is coming through, gas is coming through here, and you've got your shroud, or your nozzle as we've been calling it, your shield gas occurring at this point, and your actual arc occurring in this zone. Your gas diffuser is actually as the gas is coming out at this point, these little openings that you see right here, coming out into the shroud and then ejecting out. So, pretty simple, but incredibly handy. Oftentimes they can operate at they can consume less power and require less or not as much amount of electricity to operate, which is pretty cool. Obviously less amperage. Now, the one thing you have to understand though about this is, and I'll just draw some attention to it right now, the welding wire size, what's coming through the gun, and it's not like you get to swap that out very quickly or effectively. These things come on rolls and they have to feed all the way through the welder system to get to your gun. So sometimes you can have, kinks and that kind of thing, tangles, problems, that sort of thing. And swapping it out means you actually have to swap out the whole row, and obviously it does run out. But what wire size do you use? Well, that is controlled by the type of equipment that you have, the type of weld you're going to be doing, and obviously, very important, the type of the base metal you're going to be working with. So much like electrodes on the Gmaw, the Gmaw actually has to have swappable stuff, except the Gmaw is harder to swap. Another interesting thing is that the shroud itself can be changed in shape and can be swapped out for different types of applications. Won't go into detail on what all those are, or the reasons why, but the shape of the shroud itself can affect the weld performance. Another great little advantage of the Gmaw over the Gmaw typically is the trigger system. So for example, and I guess y'all can't see it because I'm cutting off about right here, aren't I? The trigger system actually turns everything on and off. So gas isn't flowing until the trigger's pushed. Current isn't flowing until the trigger is pushed, and obviously the wire isn't moving until the trigger is pushed. Where in the case of the Gmaw systems, usually they're hot all the time. There's not really a trigger. So, the chance of electrocuting or doing something wrong is a little bit higher. Here, everything is deactivated until that trigger is pushed, which is a nice little safety feature. Now, another little thing to point out is the gas itself. As I've mentioned, this typically we're shooting for inert gases, so it doesn't react with anything going on in here, especially with the heat intensity. We did talk about some of the ones that you can use. Carbon dioxide is one. Helium is also inert. I did say that we didn't want to use oxygen, but kind of what I was referring to is we didn't want to use pure oxygen. You can use some mixtures of oxygen, but again, oxygen is explosive in its concentrated form, so it's actually an oxygen mix with something else. But the key thing is argon's also used. That's another one that you hear people talk about using, is argon as a shielding gas. Key thing is that there's some kind of gas being pumped in here to shield the operation, much of the same way that Gmaw is, except we're just using it as a separate entity instead of providing in that flux. Another key thing about the gas, what we're talking about, is the tank, controls and the regulators on how much flow we're getting, and that also can be controlled by several different factors. But you'll notice that the tanks in the applications of Gmaws actually have certain settings. So, how much pressure we're pushing through in terms of that shielding gas is important. And just for reference, the actual amount of shielding gas flowing is actually referred to as cubic feet per hour. Now, if you're used to mechanical or ventilation and HVAC stuff, you might be used to the term cubic feet per minute, but that's a difference between an hour and a minute. That's how much cubic feet of air is flowing in a 60-second period. This one is how much cubic feet of gas is flowing in a 3,600-second period. So, a little bit difference on flows. And when might you make some field adjustments? Well, what if you're outside doing some repair work and it's a really windy day? Well, that means the air is coming through and just blowing away that actual shielding gas, which is bad for your situation. So you might have to increase the pressure to get more airflow or get more gas flow out to compensate for that. All right, so that's a good stopping point. We'll catch you on the next one.